Welcome to The Explainer. Look, let's dive right into this today because if you or maybe someone you know has been on a weight loss journey recently, what we're covering is absolutely, completely game-changing. The GLP-1 plateau and the NIH's breakthrough discovery.
Most people hit a wall with Ozempic, and the NIH just found out exactly why. Here's the stark reality. You start a GLP-1 medication, you do everything right, the pounds are literally melting off at first, and then suddenly, nothing. It just stops. It is incredibly frustrating, but now we actually know the scientific reason why.
Section 1. The Ozempic Wall.
Okay, so if you're in your 30s, 40s, or 50s and you're trying to manage your weight with these medications, this flatline, this plateau, it's probably your single biggest frustration right now. But here's the thing you really need to hear. You are not doing anything wrong. Your body is just doing what bodies do. Initially, we get this high drop, the honeymoon phase. It feels amazing. Then it transitions into a moderate drop. You're still making progress, your body is just kind of adapting. But then, inevitably, we hit that flat line, the dreaded plateau. Scientists have known for a while that GLP-1 drugs target your brain to reduce appetite. But the actual microscopic cellular reason for this flatline? Total mystery. Until now.
Dr. Andrew Ludas from the NIH really hit the nail on the head here. He says, we know much less about the nuts and bolts of what goes on within the neurons. And that's exactly it. Before this brand new May 2026 study, researchers had a massive blind spot. They knew the drug went to the brain, they knew people lost weight, but the internal machinery of those brain cells, total black box. They just couldn't explain why almost everyone eventually hits that wall.
Section 2. The brain's appetite switch. To figure this out, researchers had to zoom way in. We're talking deep into the brain's appetite center, a region called the area postrema, basically the master control room for your hunger. Inside these neurons, they looked at a specific signaling molecule called CAMP, or cyclic adenosine monophosphate. Now let's skip the heavy medical jargon. Just think of CAMP like a cellular battery, or maybe like a glowing volume dial inside your brain cells. When a GLP-1 drug like semaglutide gets into your system, it turns that dial up. It charges the battery. When CAMP is high, your brain gets the message loud and clear. Hey, we're full, stop eating. And you lose weight.
Number 1. To actually see this happen, lead researcher Dr. Claire Gao did something truly mind-blowing. She used advanced fluorescence imaging to watch living brain tissue. For the very first time, she watched this CAMP signal literally light up in single individual living brain cells in real time. Just incredible precision.
Section 3. The NIH Breakthrough.
So by watching these individual cells light up, her team found the exact mechanism behind the plateau. This is the big breakthrough. They realized that this volume dial doesn't just switch on and stay on forever. Under the microscope, they saw two totally different reactions. First, you have sustained responders. In these cells, the CMP battery stayed fully charged while the drug was present. But then you have the temporary responders. In these neurons, the battery charge spiked, but then just faded. Why? Because the GLP-1 receptors on the outside of the cell actually started to degrade. They internalized, they essentially hid away. So the drug couldn't tell the cell to turn up the volume anymore. The battery burned out. And that right there is the exact biological reason you hit the plateau.
But you know, every good explainer needs a villain, right? At the cellular level, that villain is an enzyme called PDE4. This is a naturally occurring enzyme, and its entire job in your body is to degrade CAMP. So if CAMP is your weight loss battery, PDE4 is the drain that's constantly trying to empty it. When your GLP-1 receptors degrade and hide away, PDE4 completely takes over. It drains the signal, your appetite comes roaring back, and the scale just absolutely refuses to budge.
So how do we fix this? Well, the NAI team didn't just find the problem, they actually tested a solution. Let's look at the steps. Step 1. The GLP-1 drug activates the cell and charges the battery. Step 2. That pesky PDE4 enzyme swoops in to drain the signal. But here's the magic of Step 3. The researchers added a drug called roflumilast. This specifically blocks PDE4. It literally puts a plug in the drain. By doing this, they successfully skewed the neurons toward a sustained response. They kept the volume dial cranked all the way up.
Section 4. The future of weight loss.
Let's step out of the microscope for a second. What does this mean for you? The real-world implications here are massive. If we can safely combine GLP-1s with a PDE4 blocker in humans, we could significantly extend the drug's effects, which means you could potentially reduce how often you even need to take the medication while getting the exact same or even better appetite suppression. And of course, the absolute holy grail, a targeted, proven way to break past weight loss plateaus by keeping those cellular batteries charged even when your body tries to fight back. Could this end the weight loss plateau forever? It is an incredibly exciting question to think about. Now, the researchers are careful to point out they still have a lot of work to do. So far, they've only watched this signaling happen over a matter of hours. But their immediate next step is to use new techniques to study this over days and weeks, just to make sure that plug stays securely in the drain over the long haul.
I want to leave you with this final thought from the NIH's Dr. Michael Krauss. He said, "It was not an all-or-nothing phenomenon. We observed that CAMP responses across cells varied on a continuum. You are unique. Your brain cells are unique. Some respond strongly, some fade fast. The future of weight loss isn't just brute forcing your body to stop eating. It's about understanding your unique, individual cellular continuum and giving your body exactly the support it needs to succeed long-term. Unlocking that might just be the key to shattering the Ozempic wall for good." Keep your eyes on this research. It is moving fast.